All right, chapter 4, displaying and summarizing quantitative data. So last chapter we were dealing with categorical, now we're dealing with quantitative. The primary means of displaying quantitative data is by a histogram Something to note is that histograms look like bar charts, but they are quite different. All right, I would leave a little bit of space. I'm about to draw a histogram, and then we're gonna write some stuff above it. So I would leave not a ton of space, but I don't know, a couple lines. So what you're going to notice about these is that they do touch. Okay, with the bar charts, they did not touch. With this, they do. Okay, unless I intentionally leave a gap. It's up to you. You're just kind of distinguishing. I mean, you could do every other. You're just distinguishing each box from the other ones. So it really doesn't matter. I just am because I feel like being colorful. I'm going to go ahead and draw arrows and write the stuff that fills it in, but I'll actually talk about it once everybody's kind of done so we can actually look at it. Yes. That's what they're called. I'm going to let y'all get all that, and then I'll explain it. Setting my alarm to remind me that I need to get batteries. Since I, for some reason, can't seem to remember that. Okay, so this is a histogram, okay? I said, like, don't leave gaps because that's not what a histogram is. If there is a gap, though, that means that bin is empty. So that basically means there's no data values that fill that space. So in this case, this 20 to 25 region, there was no data here. That's why there's a gap. And what you're going to see as we go through and do problems is that sometimes you may put in the stuff and it's going to give you your histogram off your calculator, and it may look like there's no gaps. But if we go and we change the window of our graph or the increments that it's counted by, we're going to see that there actually are gaps because there's things about it that we are able to answer based on if there's gaps or not. So they are really important. Don't get rid of them. Don't be like, oh, I'm just going to skip it and just smush it together. They have to be there if they exist. But otherwise, the bars are touching. The height of it is how basically many data values are in the bins. So how many things actually fit in that region of, like, say 10 to 15 had the most, 0 to 5 had the least, things like that. As far as the axis, that needs to be split into equal bins. We can't be like, well, we're going to do this one from 0 to 5, but this one from, like, 10 to 50, like, it has to be equal all the way across. Okay, you can change what the values are, but you can't change. So, like, part of our changing our window, let's say if we had done 0 to 10, we wouldn't have seen, or like increments of 10, we wouldn't have seen that there was a gap here. But by splitting it into 5s, we can see that there was a gap there, basically. Yes.
So what you're saying is the increments have to be like the same all across.
Yeah, so if you're going to do 5, that has to be 5 all the way across. If you're going to do 50, it's got to be 50 all the way across, basically. All right. Obviously, we'll do a lot more with that, but I wanted you to have a general idea of that. So, histograms can show frequency or relative frequency, which remember is a percent. And either choice will create similar looking distributions. Okay, because if you remember when we did like the 2 tables side by side and we're like, these 2 things show you the same data, it just in a different way. That's basically what it's saying here. So this next thing is very important. When you describe a distribution, always remember your socks. So you're probably thinking she's done lost it, she spelled socks wrong, this is a stats class, and she's talking about the things that go on my feet.
We definitely aren't.
Okay, well, that's good because I haven't lost it. SOX is an acronym for shape, outliers, center, and spread. And we're going to look at each of those topics individually here in just a moment. Hope you're in a drawing mood because we're going to be drawing.
You know I'm not.
Like what kind of drawing?
Drawing histograms.
Oh, okay.
Lots of them.
I can draw those.
Lots and lots of them. On Sunday, I was about to say my niece, my cousin, she's like 9, I think. Yeah. And we would just like lay our phone down with like a picture on the floor and she would literally draw it and it was like perfect. It was crazy. She drew like Bugs Bunny and the Tasmanian Devil and Pokemon, Snoopy. We just like lay it down and she would just draw it. I was like, girl, I could not draw that good. Like, wish I could, but I can't. Just like 9.5 maybe, something like that.
I can paint very well.
Yeah, I don't do any of it very well. It's not my forte, but that's okay. What?
He said a jack of all trades, but a master of none. That's so good.
It's a fair point. All right, we're going to start with shape. What does it look like? Is it? All right, I'm going to go ahead and set up 4 little mini graphs. And then I'm going to draw on them and then I'll write the name of each one. They're all going to be histograms, yes.
That's what they're called. That's the names.
Yes. And it is very important you draw them as similar in style to what I'm about to draw as possible. I'm going to let y'all get those drawn, and then I'm going to have you guess which one each name that I say is.
So, is it so are those supposed to be like different widths, like each?
They're supposed to be the same. I'm
Okay.
just,
So just pretend they're the same.
yeah. Told you I'm not a good drawer. It's just the overall shape needs to be the same.
Bye.
You tired, Josh? These like rainy days aren't helping anything. Anyway, I woke up and I was like, there's no possible way it's time to get up yet.
I had a dream this morning, and it was about bubble guppies.
Interesting.
Yeah,
I forget, that's like y'all's generation. Bubble Guppies was like very past me.
I don't know what bowling cookies are.
Did you watch TV?
Honestly, yeah, I'd have a childhood.
Well, no, I'm just asking because like my nieces and nephews like don't watch like a ton of it. They're only allowed to watch like certain things and like only like certain amounts of time a day.
Yeah, I don't
They watch Toy Story like chronically.
know. My thing, my favorite show was Octonauts.
I liked Bear in the Big Blue House.
I love my
That was more my time, but
Was it? It's on Netflix now, I think.
it's on
Or
Disney Plus.
Yeah. That was the
It's so
best.
funny. I still can quote some of the episodes.
That's the best.
All right. I'm going to say a name of one of these graphs and tell me 1, 2, 3, or 4 which one you think it is. Bimodal.
Bimodal. The
Two,
second one.
two.
The second one.
Okay, started off easy.
Yay. You're so smart.
So bimodal. How about symmetric?
4.
Yeah, that one. I say 4.
4 is symmetric. Uniform.
Third
Three.
3.
And unimodal. So when we're describing the shape, we want to say, is it unimodal, bimodal, uniform, or symmetric? But we also have another question under shape that we want to talk about, and that is it skewed? And then the way that I remember this is that the tail points in the direction of the skew. So I'm going to have two graphs. They're going to be a little larger this time, but still the same thing. Doesn't have to be exact, just similar. Like, you don't have to make sure you have the exact same amount of bars I have, just what it looks like. Also, we won't talk about how the one on the left is significantly smaller than the one on the right. It's not on purpose, it doesn't matter, it just is. It's just what feels right. I mean, after this, it won't be what just feels right, but you know.
My bars are definitely not all the same.
That's okay. All right. Which one is right skewed?
What does skewed mean?
The tail points in the direction of the skew.
Well, it would be the right skew to the right.
Mm-hmm. So
So the tail is the long part.
this would be the tail.
Okay.
So this one is going to be right skew. This one then is going to be left skew. All right, that's shape. Now we're going to look at outliers.
How much space do you think this will take?
Outliers for me is like 7-ish lines. Ballpark. Outliers, data, points that appear unusually small or large compared to the rest of the distribution. Big thing to note, not all distributions have outliers. We don't want them to have outliers, but inevitably it does happen more often than not. So this time we just need one little baby graph. All right, so an outlier is unusually small or large compared to the rest of the distribution. So which one out of the two that I colored in red do you think is an outlier?
The one on the left.
The one on the left. That's an outlier. This one probably isn't an outlier. Now, later in chapter 5 and 6, we're going to actually have a formula to test if a point is an outlier or not. But you don't need to be worried about that yet. At the moment, if it were to ask you for an outlier, you are just basically saying this appears to be, or I don't think this is. So pretty much the farther away it is from the rest of the data, the more likely it is to be an outlier.
What?
Did you do the worksheet?
I did the video, I had to do the cartoon thing now. Huh?
Cartoon.
It's like it gives you two scenarios, and then you have to explain what body or like what body systems that they're using, like the one that's running to the bathroom, or like your circulatory, your respiratory, skeletal, all those, and then you have to make your own cartoon, which I don't want to, but then you have to like make the person run.
All right, center. We can estimate the mean and or median for a histogram. So those things would be the center. The mean is the average. So we would get that by doing the summation of x divided by n is equal to x bar, which means mean. So that basically looks confusing, but it's a complex way of saying add up all the numbers and divide by the number of numbers you have. So still means the exact same thing that mean meant when you learned it the first time back in probably middle school, maybe elementary school.
So could you repeat what that says?
The summation, the funky E looking thing is a summation symbol of x divided by n being the number of numbers, is equal to x bar, which means mean. Then the median is the middle value that separates the data into two equal-sized lists. So what you're ultimately going to learn is that both of these are very useful, and dependent on the scenario we have will depend on which one you prefer to use. Okay, because when we have something that's skewed, that can affect different things. And so in different scenarios, we'll see, which one is the smarter choice. I don't think that happens in... No, it does. We will go over it at the end of this chapter, but for right now, just know that they're there. 2 ways to find the center. All right, and then finally, on to spread. State the minimum and maximum values for the data. The range, so again, should be a familiar word, is the difference between the min and max the data can be split into what we call quartiles. That indicate where each 25% of the data lies. So if you don't have a couple lines before I do this, next thing, I would make sure you have probably at least 5 lines. Because basically, I'm going to draw out the quartiles, what it means, all that stuff. All right, so Q1, Q2, and Q3 mean quartile 1, 2, and 3. Now, quartile 2 is also known as the, anybody want to take a guess? Median. So the lower quartile contains the lower 25% of the data. So basically, every arrow represents 25% of the data. And then the upper quartile contains upper 25% of the data. Now this area here from Q1 to Q3 we call the inner quartile range. Okay, also known as IQR. This is very important because IQR is going to be a part of helping us figure out if things are outliers or not. And so the interquartile range, or a lot of times you will just hear me say the IQR because interquartile range is kind of a mouthful. Interquartile range is the middle 50% of the distribution. So I think we're probably going to stop there for today because the rest of the stuff kind of all flows together. But just a little preview for tomorrow. The min, Q1, Q2, or often we don't say Q2. We actually end up calling it median just because I don't really have a good reason for it. Q3 and the max end up being part of our 5-number summary. Okay, and that's all things you can get off your calculator when we're solving a problem. It will actually give you your full 5-number summary. In some cases, it's already given to you. In other cases, we have to find it ourselves with a list of numbers. Some of it, like the min and the max, possibly the median, you could find on your own. Q1 and Q3, probably not without a lot of math. So, calculator does it for you. That's my personal recommendation to use it. But anyways, that will be our 5-number summary, but we'll look more at that tomorrow, as well as some other ways to display quantitative data, which you've probably seen before, at least a stem and leaf plot I'm sure you've seen before. And we'll talk a little bit about standard deviation as well. So anyways, that's going to be it for today.